part. Okay. Actually, if you still remember that in the previous chapter, right? Especially chapter 6, that the thermodynamic properties is for the composition is constant or for the fluids. Okay, and the previous one is we can consider that composition as a primary variables lah. Okay, because there is a no change on the composition, right? Okay, so we did not consider there's any change in the composition. We just make it as a constant. Okay. However, in the chemicals plant or petroleums, or other else of polymer or pharmaceuticals, they involve a multi-component gas or liquids. Okay. So there's gonna be a change in the compositions. Okay. Uh, this is maybe from the mixing. Okay, a separation process. Okay, maybe the transfer of the species from the liquid to gas, right? Especially from one phase to another phase, and maybe there's some chemical reaction also. So that properties, okay, actually is depending mainly on the composition. Okay, not only temperature and pressure as well as composition. So you have to. So for this part, we have to consider that the composition. This is if you learn in the mass and energy balance, right, on the binary system, right? So you have to find the composition for each temperature and also for each pressure. Okay, it's not constant as anymore. So that's why it's important. But we're gonna deal with the real fluids, lah. Okay, mostly or vapor. Okay, vapor and also liquid. Okay. Okay, so for this part, first, of course, introduction, but mostly on the theory lah. What is the chemical potential? What is the partial properties? Okay, uh, I think all of you know what is the partial properties. One of the example is the partial pressure, right? Okay, okay, and then chemical potential and phase equilibrium. This one is what is the chemical potential? Okay, later I will ask you what is chemical potential. What is, do you understand about the chemical potential? Okay, please prepare with the answer. Okay. Pure partial and solution properties. Pure properties, what is the symbol, partial and the solution properties? Still the same, we're gonna determine the volume. Okay, what else? Entropy, enthalpy, and so on. Okay, that related with the thermodynamic properties. First is for the ideal gas mixture and ideal solution and Lewis Randall rule. Okay. Then is a fugacity and fugacity coefficient. This is I think is the main part of the uh, for this uh, for this chapter. Okay, how to determine the fugacity from the fugacity coefficient. First, we're gonna learn how to determine the fugacity coefficient by using a pure for the pure for the pure species, and then solution for fugacity and fugacity coefficients. What else? How to determine the fugacity coefficients, residual properties relations, fugacity by using virials, generalized correlation also. This is you need the knowledge from the chapter, previous chapter. Okay. How to use the virial. I think the easiest one is virial. For actually not only virials. I think we're gonna focus also on the, yeah, mostly is virial. Okay, mostly virial for the binary system. Okay, since for the cubic equation of state we did not cover. Okay, we can use a generic cubic equation of state, but I think it's gonna take quite long steps lah. Okay, uh, it's a quite difference lah, as compared with the I think you need the information from the chapter 3 also. Okay, to determine I, Q, and Z. Okay, for if you use a cubic equation, but we will not cover that the cubic equation state to determine the fugacity coefficient. And then excess properties. Okay, excess properties is for the solutions. Okay, we cannot use it for pure substance. Okay, but residual, yeah, residual properties we can use it for the uh, pure species and also the solution lah. Okay, okay. So I think for this chapter we will cover on the introduction, fundamental properties, chemical potential, and physical graph, partial properties, and ideal gas mixture. Um, uh, I'm not sure for today's. I think maybe about the chemical potential and partial properties. I think. Okay, we will let's see until where we will stop lah. Okay, so actually for this part is we're gonna go through on the derivation of the fundamental properties relations. Okay, mostly on how to determine fugacity, okay, for the homogeneous solutions. Okay, and what is the chemical potential? What is the partial properties? Um, okay, about the introduction onto the solution thermodynamic. Okay, why I say that solution because we already involved on two phases. Okay, liquid and also vapor. We call it fluids lah. Both liquid and vapor we can define as the fluids. Fluids not only liquid, but it's both vapor and liquids. Okay, for example, streamline, right? This one. So we know the single component system that most common thermodynamic properties is variable is temperature and pressure. So we know how to determine the saturated temperature, okay, vapor pressure, enthalpy, and change in the enthalpy, right? Liquid volume for liquid, okay, ideal, non-ideals, okay. What else? The heat transfer, right, and the entropy. But for the mixture, okay. If for the equation, you still remember that H equal to summation of y h I, right? This one is for the vapor phase. So this is the only ideal for the valid for the ideal mixture, because in real system, okay, um, uh, this is not ideal lah, because the real, if you mix 1,000 of the of, for example, the what is it, component A and 1,000 cubic meter of the uh, component B. If you mix together, if ideal, is become 2,000. Okay, but it's not ideal in the real system. Okay, when you mix both, it's gonna be less. Okay, why? Is because of the partial properties lah. Some of the uh, what we call it as a some factor is because of the partial properties of the component. Okay, so both system, if you look at here, that A and B, right, both system at the same temperature, pressure, and N, but different composition. Okay, if you look at here, that yellow on the for A, right, for system A is 3 yellow, for 4 red, okay, and also 2 black. Okay, but for B is a 3 red, okay, 1 yellow, okay, 2, there's another blue color here, so it's a different combination. Okay, so if you assume, okay, for other mixture, actually the um mix, right, the composition is not same. Okay, of course, in terms of enthalpy, is gonna be not similar as a pure, what we call it, as a pure component, right, when we mix. Okay, it's going to be different. So we have a new thermodynamic properties for the multi-component system. Once you mix both A and B, we call it as composition lah. Generally for X is we use it for liquid, right? Okay, this one is for the liquid, and this one is for the vapor or gas. Okay, why? The composition. Okay, composition is going to be changed. So, for the example for non-ideal mixture, if you look at here, that for the process involve that multi-component system, we consider that 1,000 cubic centimeter methanol and 1,000 cubic centimeter uh, of the water at 25 degrees C. if it's ideal, is equal to 1000, right? But if non-ideal, in fact, is only 1970 cubic meter of the solutions. Okay. Okay. So this is the real facts lah, because we deal with the real system, which is contains a mixture of fluids. Fluid, this is a vapor and also liquid lah. Okay. So main objective, of course, we're gonna develop the theoretical foundation of the thermodynamic of gas mixture and also liquid solution. So you have to know what is the chemical potential, partial properties, fugacity, exact properties, and ideal solution. Ideal solution is for liquid. For example, the basis for the real gas, the fundamental is ideal gas, right? For non-ideal solution, the basis is ideal solutions. It's like a reference. Okay. Okay. So if you look at here, if we assume that ideal solution, okay, here lah, okay. So generally the partial properties, okay, they have a bar here on top, okay. So for the mixture, right, okay, there's a xi vi, there's a partial, okay, the actual is actually 0. So we can calculate from this one for the density. So please remember, there's a symbol on top here, we call it a bar. There's the bar or H. This is a symbol of the partial properties. Okay. So it's not similar as 1 divided by summation xi vi. Okay, because pure components, the properties is different. Once we mix with the other components, it's going to become the difference. Okay, so this is why we introduce neutral properties, what we call it as a partial properties. Okay, so partial properties is the it's going to be difference. Okay, this is an individual species that exist in solution. Okay, for examples, partial properties. Okay, uh, you have a ethanol and also water, right? Okay, these two species has partial molar properties where the value as this is different from the pure ethanol and H2O at the same temperature and also pressure. Okay, for example, if you have uh, ethanol and water, once you mix, is different with the pure one. Okay, the partial molar volume. Okay, okay. So another one is the chemical potential. Okay, so what do you understand about the chemical potential? Have you learned about the chemical potential? If partial properties is the properties of the individual species, right, in the solution. Okay, um there's gonna be the difference, okay, with the pure species. Okay, anyone can answer? What do you understand about the chemical potential? Let me see. So please find the answer. Okay, I will ask again. I just randomly pick up one name. Okay. Okay. So let's see the fundamental properties relations. This one I think is more on the theory. It's quite difficult to explain actually. Okay. Our actually our problem is how can we determine the phase of the multi-component system, and also if there is a two phase, okay, how can we determine the composition for each phase, right? So that is the problem. In chapter 10, I think you're gonna learn by using what is it? Uh, binary mixture. bulk point calculation, dew point calculation, that one you can determine the composition lah. So this one we just calculate the theory how to determine the fugacity. And then chapter 12 more on the activity coefficient. Because if vapor phase is non-ideal, you have to include the fugacity coefficients. You have to calculate the fugacity coefficients. Okay, if the liquid is not non-ideals, you have to calculate the activity coefficients. Okay, you cannot simply neglect the fugacity and also fugacity coefficient as well as the activity coefficient if non-ideal fluids lah. Okay, so you have to remember. Okay, because we are deal with the real system. Okay, so let's see the fundamental properties relations. This one. I think it's more on the relationship between temperature, pressure, and Gibbs energy lah, on the composition. So if you still remember that G equal to V dP and S minus S dt. So this one if in term of the partial properties, right? Partial Gibbs energy. Okay, as a function of temperature and pressure, right? Okay, this is a closed system. So for the open system, also we consider as the open system multi-components. So the Gibbs energy we can write as a function of the pressure, temperature, and different composition. Okay, this is going to be different composition. It's not fixed anymore here. You have to remember that because we are now dealing with the compositions. So since if we apply the partial differentials to the FPR, so if you look at here that for the partial properties relations equations here, right, previous one, there's a additional equation here actually. Okay, this is a partial Gibbs energy lah. This partial Gibbs energy actually is a chemical potential of the species I, because this one I, right, in the mixture. Okay. Okay, so you have to remember they have another term here. Okay, previously it's residual, but that one is only pure substance. But now you deal with the composition, a multi-component system, a multi-components. What else? System and also composition, right? So they have a chemical potential here. Okay. So we can define in general chemical potentials. Also, we can define as a partial Gibbs energy lah. Okay, so if relate with Gibbs energy in equilibriums, okay, the chemical potential is going to be zero. Okay, you have to remember any related with the Gibbs energy in equilibrium is going to be zero. Okay, previously also, right, for the substance, right, equilibriums Gibbs energy is going to be zero. Okay. So if you look at here, that's once we substitute here with the chemical potential, right? So they have additional equation here. Okay, and this is the chemical potential. One of the chemical potential is the fugacity. Okay, what is the fugacity? So please find the answer. What is the fugacity? What do you understand about the fugacity? Later, once I give lecture on the fugacity, I will ask again. What is the definition of the fugacity? For now, I want to ask you what is the chemical potential. Okay. So there's the additional lah here. There's nothing. Okay, so the question is, as I told you that how can we determine the phase of the multi-component system and how can we determine the composition for each phase? If you have two phase, liquid and gas, so how can we determine the composition? Okay, so before answering these questions, okay, so you need to establish the concept of the phase equilibrium for the multi-component system. Okay, anything it should be in equilibriums if you want to calculate the composition. Okay. So if you look at here that if we consider that chemical potential, if you consider the closed system multi-component, okay, and alpha and beta, right? Because they have a two phase here. If we consider here is a vapor and liquid, right? Okay, and alpha and beta. Okay, in equilibriums, and alpha is going to be similar with the n and beta. You have to remember because it's partial Gibbs energy. Okay, so for the open system, of course, is related with the fundamental properties of relations, and here is for alpha phase, and this one is beta phase lah. If this is a liquid and this one is for vapor, okay. See? So what happen if in equilibrium? Okay, so in equilibriums, okay, if you look at here that the chemical potential is will be the same vapor and liquid. Okay, similar also for the fugacity, because fugacity is one of the chemical potential. Fugacity, if you have many phases, it's going to be same. Okay, liquid, vapor, uh, F alpha equal to F beta, or mu alpha equal to mu beta equal to mu gamma, and so on. Because in equilibrium, the summation of the chemical potential is equal to zero. Okay, this is equal to zero. Okay, this is the summation. You have to know. Okay, so the criteria of the chemical potential, if you look at here, that okay, if you apply until pi phase, meaning that infinity, mu v equal to mu l equal to mu beta equal to mu alpha, and so on. Okay, more than two phases. Okay, so this is the criteria for the multi-component system in equilibrium. Okay, multi-phase at the same temperature pressure are in equilibrium when the chemical potential of each phase, each species is same in all phases. Okay, you have to remember. So back to the question, what do you understand about the chemical potential? What's the definition? Anyone? Apa? Nick Amirul Haziq? Nick Amirul Haziq?
Yes, Doctor.
What do you understand about the chemical potential?
I see chemical potential as if it is like actually potential energy, where potential energy change to kinetic energy, but here for chemical potential, you change to chemical reaction.
That one is from the internet, right? From the website.
Uh
What
yeah.
do you understand? Apa yang you faham tentang chemical potential? Of course, it's related with the energy, right? The absorb or release lah. Due to the change in the particle number, right?
Yes, Doctor.
In the chemical reaction. But what do you understand about the chemical potential? Hmm. Apa yang awak faham? Any macam persamaan ke with other panggil apa? Yang you faham tak semestinya, not really on the chemical potential, but in your daily life, what do you can relate in your daily life around you? What do you understand? Azima? Yeah, Azima. Of course, it's yeah. This is about the energy lah. Okay. Partial molar free energy, because it gives energy, right? Whether you absorb or release during the chemical reactions. Or there's a phase transition. Phase transition meaning that species from liquid to the gas. All right. There's a species release, flee from the liquid to the gas. But what do you understand? Azima ada Azima.
Yes, doctor.
What do you understand about the chemical potential?
Um, Maybe the ability for the chemical to perform works. Maybe
Example?
uh, example, like absorb or release heat.
Itu saya dah kasih tahu dah tadi. What do you understand? What you can relate with the around you lah. Hmm. Hmm. Maybe one example. Okay, the movement of the chemical potential from low to high or high to low? Anyone? The movement. All species have a chemical potential, right? Okay, yes, from high to low. Okay. Okay. From high to low. Okay, anyone can give the example? Maybe can relate with the concentration or phase. Based on the phase or concentration. You can see actually, you can know. Hmm. You boleh relate kan, for example. Oh, anyone? Hmm. Afika? Afika ada Afika? Afika Siddiq. Eh, dah 4:40. Kejap ya. Afika ada Afika? Afika,
Ya, doktor.
can you give the example about the chemical potential? The movement from the high chemical potential to low chemical potential.
Kalau kat enjin,
Apa dia cerita lah. Engine.
oh, tak.
Apa tadi engine? Tak apa, boleh je explain. If you can explain in English, you can explain in bahasa. Even I prefer to bahasa. Ada? Hafizah? Tak tahu.
Tak tahu nak explain, doktor.
Tak tahu. Okay. Okay, yeah, when the movement of the molecules from the higher chemical potential to the lower chemical potentials, generally is going to absorb or release the free energy lah. Okay. So this is the reaction we call it as spontaneous. Okay. So meaning that naturally is can move lah. Like a previous one when we talk about the entropy, right? Okay, from positive. It should be positive to negative. It should be positive lah, your entropy. So they can naturally is the move. Okay. So one of the example is if involving the if there is a on the face lah, for example of the face, right? If you have a glass of liquid water and also ice cube, right? Okay. So for example, if above 0 degree, right, the water is gonna be in liquid phase, while ice cube of course is solid phase, right? Okay. So if above 0 degree C, some ice will melt. Okay, it's gonna be melting stuff, and H2O is gonna be convert from solid to liquid. Okay, because H2O have lower chemical potential. Okay, so that's why water have lower chemical potential, the liquid lah. Ice cube have higher chemical potential because the movement of the chemical potential from uh, uh, higher chemical potential to the lower chemical potential. That's why the what is it, the ice cube is melting, okay, easily to melting above 0 degrees C. Okay, in opposite, okay, if below the 0 degrees C, okay, the chemical potential for the ice cube is lower, while for the water is higher. So that's why the ice cube is grow, right? For if above 0 degrees C, the ice cube is going to be shrink, right? But if at 0 degrees C, right, 0 degrees C, okay, as I told you, right, in equilibriums, okay, the summation of this one, right? The summation of where is the chemical? Okay, where's the summation of the chemical potential? This one. The summation of chemical potential is equal to 0. Okay, so meaning that neither the ice shrinks or grow. Okay, that's why ice cube is not gonna be dia tak akan naik ke liquid ataupun dia tak akan grow lah. Dia is gonna be maintained at the degree C. This is one of the example that related with the chemical potential. Okay, it's like if in the physics, right, there's a potential, right, physics. When you roll the ball through the downhills, it's gonna be moving easily, right, from the higher gravitational potential to the lower gravitational potentials, rather than you push from the downhill to the uphill, right? Okay, this is what we call it the spontaneous process. That one is we want to relate with the physics. Okay, okay, understand or not? What else? That one is in term of phase now. If concentrations, we can relate with the what is it? If the concentration, we can relate with the diffusing of the maybe like gas in the homogeneous environment side. Okay, so you can relate with the higher concentration to the lower concentrations. Okay, or do you know why the vinegar is a little bit acidic? Okay, it's also related with the chemical potentials. Okay, because it's gonna produce, because acetic acid is gonna the bond of CH3COO is gonna be cleaved to form H plus and also no, CH3COO minus and also H plus. Okay, so generally if during the reaction, the vinegar, the CH3COOH is going to be reduced lah. The chemical potentials, because it's going to be shift to the right side, and the concentration of CH3COO and also OH plus is going to be increased. Okay, so this is the reason why vinegar a little bit acidic. Okay, because reducing the hydrogen ion. Okay, done in the solutions. Okay, but in equilibriums, you have to know that the reaction is reversible. Okay, that's why CH3COOH is going to be reversible reactions, produce CH3CO minus plus H plus is a reversible. That's why vinegar is a little bit acidic. Okay, because of the lower chemical potential in acetic acid to produce H plus, which is more acidic. Okay, okay. Faham ke tak faham? Do you have a general overview about the chemical potential? Can you relate with the reactions? Okay, when the dissolve meltings. Okay, okay, okay. So that is about the chemical potential lah. Later we will learn about one of the chemical potential, which is fugacity lah. Okay, the potential of the species to flee from the one phase to another phase lah. Okay, it's gonna be fugacity is for the vapor. Okay, activity coefficient for the for the liquid. Okay, so now it's 4:50. Any questions? I think we will stop here. Or you want to continue? Partial properties. Partial properties, maybe we continue for the next class. Okay, so your assignment first, please, I will ask what is the partial properties, and then Fugesti. That is the definition of what do you understand about the Fugesti. Okay, that is the assignment. I will ask again in the next class, especially on the Fugesti lah. What do you understand about the Fugesti? Because of course we will calculate the Fugesti from the Fugesti coefficients. Okay, but I need you to understand what is the Fugesti coefficient, and what do you understand about the partial properties lah. Okay. Any questions before we stop? Almost 5 o'clock. Today is very short. So when we'll start the physical class, I'm not sure. This week I don't think we can start with the physical class because they are preparing. Okay, all the academic stuff, preparing the lecture halls and also the class. I will inform later, maybe by next week or another 2 weeks lah. Okay, I'm not sure. I have to how to say? Is everybody already in UTM or not? Okay, I just want to make sure. Everybody in UTM, right? If no response, I just by next week we will have a what is it, the physical class. Everybody. So since no response on the, I'm not sure. Everybody in UTM? I'm positive COVID. Zulhani Fazrin. Okay, positive. Okay. So yeah, maybe in 1 or 2 weeks lah. Okay. Let's see, and I ask again. I will confirm again. For this week, we cannot do the physical. Okay. They are preparing all the stuff, preparing the class, and also lecture hall. Okay. So if there's no questions anymore, thank you very much. Okay, see you again on the next class online.